Hi everyone, this is lecture 12 in analog circuits. In this lecture we will discuss about the shunt clippers, or we can say parallel clippers. In this shunt clippers also we'll have two types, as we have seen for the series clipping circuits. So first is unbiased shunt clippers and the next one is biased shunt clippers, or we can say parallel clippers. Now first we will see the unbiased shunt clippers. So again in this also we'll have negative clippers and positive clippers. Now why these clippers are called shunt clipper means the diode D is parallel to the source, that is the here we see this is the source and this is the diode. So the diode is parallel to the applied source voltage, right? So this is the resistance, series resistance, and we will take the output across the diode. This is the V0, this is the D. So this is the shunt clipping circuit, and I can take the input as a sinusoidal waveform minus Vm. This is the Vm, this is Vi. Now we need to draw the output waveform and we have to give the name of the circuit. Is it a positive clipper or negative clipper? Now we will use the same approach as we have used for the series clipping circuit, that is open circuit method, right? Now how to find is, so there is a reference voltage, reference terminal. So this is the cathode voltage and this is the anode voltage. Now if I open this diode, VA will be connected to VI, VK is connected to the ground. So VA is equal to VI, VK is equal to 0, right? Now the first scenario, if the diode D is ideal, if the diode D is ideal, VA should be greater than VK. When VA is greater than VK, that is VI is greater than 0, the diode D is on, or we can say forward bias. When the diode D is on, first condition, it will be replaced by short circuit. Now the circuit will be like this. This is R, now this is short circuit. Now this is plus minus Vi. Now tell me what is V0. This is the ground. So this is a short circuit. That means V0 will be simply 0 volt, right? So that is the first condition. Now what is the second condition? Just opposite. That is, when Vi is less than 0, diode D will be off. When it is off, open circuit. Then the circuit will be R. This is open. So this is. So we applied the negative half cycle. That is the meaning. Now tell me what is V0? The same as Vi, or we can say negative half cycle. Now I will draw the output waveform. When Vi is greater than 0, what is V0? Simply 0. When Vi is less than 0, what is V0? It is following Vi, right? Because see, it's when it is an open circuit, there is no current flows. That means the drop across the resistance will be 0. And if I apply the KVL, we will get V0 is equal to Vi, right? So this is T minus Vm, this is Vm, this is the Vi. Now this is the V0. So this portion is when Vi is greater than 0. When Vi is greater than 0, V0 is 0. So 0. Next, when Vi is less than 0, there is a negative half cycle. V0 is Vi. That means V0 is following the input signal. So that means we'll get the negative half cycle. Next, positive half cycle come means 0. Then negative half cycle and so on. Right? So only we'll get negative half cycles. Now give the name of this circuit. What is this? It is clipping positive half cycles, positive portions. So we can say positive shunt clipper. Is it biased or unbiased? Unbiased. So unbiased positive shunt clipper. unbiased positive shunt clip. So this is when the diode D is ideal. Now when the D is practical, diode D is practical, that means VD on is 0.7 volt. So the circuit is same, R D VI, this is V0. Now the scenario, the cases will slightly change. The first case, the VA minus VK, the difference between the anode voltage and cathode voltage at least should be greater than 0.7 volt. So this is the VI minus 0 greater than 0.7. So when VI is greater than 0.7 volt, right, the diode D will be on, so will be replaced by a voltage source of 0.7 volt, right. Now that means when I am giving the positive half cycle and VI should be greater than this 0.7, this is resistor R, so diode D will be replaced by a voltage source 0.7. Now tell me what is V0. So V0 is, parallelly voltage will be same, V0 is 0.7 volt, right. So previously it was 0 because we have taken D as ideal. Now we are taking as a practical, so it will be replaced by 0.7 volt. The second condition is as it is opposite, VI less than 0.7, so diode D is open circuit. So when it is open, what is V0? Simply VI, that is something like this. This is R, this is open circuit, this is I am giving negative half cycle. So what is V0? This is the VI, so V0 simply VI, because open circuit no current flows, so V0 is equal to VI. Now if I want to draw the output waveform, this is the VI. Now if it is a practical, so there is a 0.7 volt, this is VM minus VM, so we can take the values of VM also, 5 volt minus 5 volt, 10 volts minus 10 volts, etc. No problem. Now to draw the output waveform, so when VI is greater than 0.7, what is V0? 0.7 volt, so that means 0.7, and when VI is less than 0.7, it will follows the VI, I mean output follows the input, so we'll get something like this. So when VI is greater than 0.7 volt, then it will follow and so on. So here also same like this, right. So this is the output waveform when the diode D is practical. So up to 0.7 it will go. Again it is positive clip only, so it is unbiased positive shunt clipper. Now if I want to make the negative clipper, what we need to do? We need to just reverse the diode, right. That is the second circuit. This is the VI R, so if I just reverse the diode, so we'll get negative clipping, right. So that is here I am taking V0. So again, if the diode is ideal, the first scenario, diode is ideal, right. Now what is VA now? So this is the reference point, so VA is now 0, VK is now VA, so this is the VK, this is the VA. Now the first condition, VA is greater than VK, so diode D is on, right. So what is VA? 0, greater than VA, that means what? When VA is less than 0, the diode D is on, that means it will be short circuit. So that means first we need to apply the negative half cycle. So if I apply the negative half cycle, this is R, so this will be short circuit, this is ground. Now tell me what is V0? Short circuit means simply 0 volt, right. Now the second condition, opposite, when VI is greater than 0, diode D will be off. So when it is off, open circuit, so I am applying the positive half cycle, this is VA. So what is V0? Simply VA, right. So it is allowing the positive half cycles, it is now stopping the negative half cycles or clipping the negative half cycle or removing the negative half cycle. So output waveform, this is Vi, this is V0. So see, when Vi is greater than 0, V0 is equal to Vi, so it is allowing positive half cycle. For negative half cycle, V0 is 0, 0 and so on. So this is Vm. So it is clipping the negative portion. So what is the name of this? Unbiased negative shunt clipper. Right? Now this is for ideal case. When it is practical, the diode D is practical. So can you expect what is the waveform we will get? Simply this will be down to minus 0.7. That's it. Right? So if the diode D is practical, so what is the first condition? Va minus Vk should be greater than 0.7 volt. 0 minus Vi greater than 0.7. That means what is this? Vi less than minus 0.7 volt. Diode D will be on. So that means the circuit will become like this. See the polarities of the diode. That is, the P side, that is P type semiconductor is down and the N type semiconductor is on top. So that means the battery polarity, that is downside is positive, top is negative. So here negative, then positive. This is 0.7 volt. So what I am applying? I am applying the negative portion, that is when Vi is less than minus 0.7. Now tell me what is V0. V0 is not 0 now, it is minus 0.7 volt. Right? Then what is the second condition? So very simple. Opposite. When Vi is greater than minus 0.7 volt, D off. So when it is off, open circuit. So I am giving positive half cycle. So what is V0 now? No current flows. So what is current? 0. So no drop. So V0 is equal to simply Vi. Now I am trying the output waveform. Vm minus Vm. This is Vi. Now there is a minus 0.7 volt. Right? Now if I want to draw the output waveform, this is the V0. Now when Vi is less than minus 0.7, V0 is equal to simply minus 0.7. So here we will get minus 0.7. Here we will get minus 0.7 because this is Vi less than minus 0.7. When Vi is greater than minus 0.7, V0 is equal to Vi. So it is following just Vi and so on. Right? So still it is unbiased negative shunt clipper. Right? So these are the two circuits in unbiased shunt clipping. So that is, the first circuit is like this. This is R, diode D. This is the Vi. So Vi can be square waveform, triangular waveform, sinusoidal waveform. So if I take the output V0 here, so what is this clipping circuit? It is clipping, see when Vi is greater than 0, short circuit, so V0 is equal to 0. So it is clipping the positive half cycle or positive portion. So we can say positive clipper. So is it parallel or series? So it is a parallel clipper, or we can say shunt clipper. See this. So to the input voltage, the diode D is parallel. Right? The second circuit is just if I reverse the diode, we will get the negative clipping. So this is the again Vi, resistor R. So when I reverse the diode, what we will get? We will get negative clipper. Negative clipper. So don't remember the, so if the arrow is looking downward, it will clip the positive portion. If the arrow is upward, it will clip the negative clipper. negative portion, right, or negative clipper. So just remember the operation. When Vi is greater than 0, short circuit, V0 is equal to 0. That means it is clipping the positive half cycle. When Vi is less than 0, open circuit, so V0 is equal to Vi. So it is allowing the negative portion. Similarly, when Vi is less than 0, it will become short circuit. That means it is not allowing the negative portions. When Vi is greater than 0, open circuit, V0 is equal to Vi. So it is allowing the only positive half cycles. So that's why it is clipping the negative portion. That's why it is called negative clipper, right? Now we will see the biased, the shunt clippers. So biased shunt clippers. So what is the biasing means? We need to add some DC source. So I can add anywhere. This is the resistor, this is the diode. If I add a voltage here, okay, I will take now the V reference something, right? So like variable voltage, this is Vi. Here I will take V0. Now if there is no V reference, it is, what is this clipper? It is positive clipper, because when Vi is greater than 0, short circuit. So even though we add some V reference, it will do the positive clipping only, but based on this reference voltage, it may go up or it may go down, etc. Now we will see the operation. So this is the diode D. Now, so what is the first condition? If the diode D is ideal, then the first condition is, this is Va and this is Vk. So when I open this diode, Va is connected to Vi, Vk is connected to V reference. So Va is equal to Vi, Vk is equal to V reference, right? Now when Va is greater than Vk, the diode D is on. So that means Vi is greater than V reference. Then the diode D is on, so it will be replaced by short circuit. So replaced by short circuit. So the circuit will become, this is short circuit, then there is a V reference. This is the Vi, which I am applying positive half cycle. Now tell me what is V0. V0 is equal to simply V reference. That is the first condition. The second condition, so opposite, just simple. When Vi is less than V reference, the diode D is off. When it is off, simply open circuit. This is resistance R, open circuit. This is V reference, this is Vi, and I am applying V less than V reference. Now tell me what is V0. So open circuit means there is no current flows, so apply KVL like this. So what is V0? Simply Vi only, right? So don't apply the KVL here because it is open circuit, so no meaning at all. So apply KVL like this. That's it. So the first condition is V0 is equal to V reference when Vi is greater than V reference. V0 is equal to Vi when Vi is less than V reference. If you observe, it is looking like the practical diode case. So if we assume V reference is equal to 0.7, so it is Vi greater than 0.7, Vi less than 0.7, right? So now how to draw the output waveform. So this is Vm, Vi minus Vm. Now I have to take the some reference level. So here I am taking the reference, that is V reference. So we can take the numerical value as 2 volts, 3 volts, and so on, right? This is T, this is V0. So when Vi is greater than V reference, so what is V0? Simply V reference. So V reference, V reference. This is V reference. Now less than V reference, V0 is equal to Vi. So just follow this like this and so on, right? So what is this clipping circuit? Again it is clipping the positive portions only, but it is biased now. So it is biased positive shunt clipper, right? So we already given the biased shunt clipper, so no need to give again biased. So simply we can say positive clipper, right? So we can make this V reference as 2 volts, 3 volts, etc. So that I will see some example. So this is the first circuit in biased shunt clipper. Now the second circuit I will take as a numerical values. Suppose this is some square waveform, something like this. This is the Vi. So 5 volt minus 5 volt. See, starting is negative half cycle, no problem. This is R, diode D. Then suppose if I take 3 volts. Now what is the output? So what is the output waveform? So very simple. So this is directly I can say Vi, this is 3 volt. So we can analyze on the circuit itself when the diode is ideal. Simple. When Vi is greater than 3 volt, so diode D will be on, replaced by short circuit. So what is V0? Simply 3 volt. No need to draw the circuit. So short circuit 3 volts. Opposite, when Vi is less than 3 volts, diode D will be off. When it is off, so no meaning of this path, simply V0 is equal to Vi. That's it. Now how to draw the output waveform? So starting is negative half cycle. It's no problem. This is the input waveform Vi. This is 5 volt minus 5 volt. Now there is a reference level, that is 3 volts. This is the 3 volts. Now see, this is T, this is the V0. Now the negative portion, that is less than 3 volts, what is V0? Simply Vi. So that means so the total negative portions will come. So when Vi is greater than 3 volts, what is V0? Simply 3 volts. So it will be stopped here and so on, right? So what is this? Minus 5 volt. The maximum we will get 3 volt, right? Now the peak to peak is changed. This is peak to peak is 10 volts. What is the peak to peak? This one only 8 volts. So again, what is this clipping? It is clipping the positive half cycles, so positive clipper, right? So this is the for ideal case. So we did not discuss about the practical case of this first circuit. So the same circuit I have to take, and we have to go for when the diode D is practical. So when the diode D is practical, so the same circuit I will take. R, diode D, V reference, this is the V0, this is the source, Vi. So in the textbook also they will take Vs also, no problem. Now again the same approach. The first condition, Va minus Vk should be greater than at least 0.7 volt when the diode D is practical. Now what is Vi here? So Vi is Vi, Vk is V reference. So Vi, Vk, V reference. So Vi minus V reference should be greater than 0.7, or Vi should be greater than V reference plus 0.7. So this 0.7 will be added. Diode D will be on, will be replaced by a 0.7 voltage drop. Though the circuit will become R 0.7 V reference. This is V0. This is Vi, which will be greater than V ref plus 0.7. Now tell me what is V0. So apply KVL. So what we will get? 0.7 plus V reference minus V ref minus 0.7 plus V0. So V0 is equal to 0.7 plus V reference. This is the first condition. So what is the second condition? Very simple. When Vi is less than V ref plus 0.7, diode D will be off, open circuit. So what is V0? Simply Vi. No need to draw again the circuit. So when it is off, open circuit, no meaning to this path. So simply apply this KVL. So current is 0, V0 is equal to Vi. Now how to draw the output waveform? Suppose again I am taking the sinusoidal. this is the Vi, Vm minus Vm. Now what is the reference value now? Now it will become Vref plus 0.7. So Vref plus 0.7. So this is the no reference value. Now when Vi is greater than Vreference plus 0.7, so what is V naught? 0.7 plus Vref. So simple, we'll get like this only. So total negative half cycle will come, then positive half cycle up to Vref plus 0.7 V naught. Right? So what is this? Positive clipper. So already biased shunt clipping is already given, so biased positive shunt clipper, so no problem, right? Now this V reference can be negative value also, right? So that will become another circuit. So I think third circuit, resistor R, diode. Now if I take directly, I will take some numerical value, suppose 1.5 volt. This is Vi, this is V naught. Suppose if I want to draw the output waveform, suppose input signal waveform is given like this. Suppose I will take triangular waveform, sorry, like this. So this is suppose 6 volt minus 6 volt. This is Vi. Now to draw the output waveform, what we need to do? So I will go for practical case, no problem. So when the diode D is practical, so that means what? See, this is Vi, this is Vk. Remember, when we open the diode, then only this is Va, this is Vk. So when it is not open, it is not Vi, okay? So for analysis purpose, we are opening the diode and we are finding the Va and Vk. So you may be confused. So how this can be Vi, even though there is a resistor R? When it is open, then only it is Vi, right? Now when the diode D is practical, so the Vi minus Vk should be greater than at least 0.7 volt. So the anode voltage minus cathode voltage should be greater than 0.7. Sorry, this is Va, which is Va. Vk is minus 1.5. So Vi, anyway Vi is already given. What is Vk now? Vi minus of minus 1.5. So it will become plus 1.5 greater than 0.7. That means what is Vi? Greater than minus 0.8 volt. When it is like this, the diode D will be on, so replaced by a 0.7 drop. So thus it will be like this, or there is a drop. This is 1.5. Now tell me what is V naught? This is 0.7. Apply KVL. 1.5 minus 0.7 plus V naught is equal to 0. So what is V naught? Minus 0.8 volt. Right? Now the second condition. This is the first condition. The second condition is just opposite. When Vi is less than minus 0.8 volt, diode D will be off. So what is V naught? Simply Vi. Right? So for negative half cycle, we'll get V naught is equal to Vi. This is T. Six volts minus 6 volts. This is the Vi. Now what is the reference value now? Minus 0.8 volt. So somewhere here. Minus 0.8. Right? This is T. This is V naught. Now when Vi is greater than minus 0.8, what is V naught? V naught is equal to minus 0.8. So that means here this is minus 0.8. When Vi is less than minus 0.8, this portion, what is V naught? Vi. So we'll get like this and so on, right? It is totally clipping of the positive half cycle and some portion of the negative half cycle also, no problem, right? So again it is a positive clipper with biasing only, but that biasing voltage is negative. So sometimes some books you may have seen like this, positive clipper with negative biasing voltage or reference voltage, right? This is also we can give name, positive clipper with positive reference voltage, positive clipper with negative reference voltage, negative clipper with positive reference voltage, negative clipper with negative reference voltage. That is also possible, right? So this is the waveform of this circuit when the V reference is negative value. It is still positive clipper only, but the reference value or biasing value is negative value, right?